Hello, welcome back. I'm here today with another problem, another nice problem. And today we have a nice number theory problem, and we should solve it in z, in integers. So let's just first simplify a bit this equation. So this would be if we just simplify xy2 and yx2 from both sides, we would have x plus y equals x3 plus y3. And to solve this, let's take these to here, and we would have x to the power of 3 plus y to the power of 3 minus x minus y equals 0. So if you pay attention to this, this is the sum of cubes, which we can factorize it as x plus y times x2 minus xy plus y2, and here is plus minus x minus y equals 0. So we also can factorize x plus y from here, and our equation would be x plus y times x2 minus xy minus 1 plus y2. So for this to have answers, either this should be 0 or this should be 0. For the first case, let's write it x plus y equals 0, and then x equals negative y, and we have the set of answers as k, negative k, and this form would be our first set of answers, and k is integer. So, and for the second case, in order for this equation to have answered in integers, I'm going to write the discriminant in terms of y, the discriminant in terms of y. So our discriminant would be y2 minus 4, y2 minus 1. So our discriminant would be negative 3y2 plus 4. So in order for this to have answered this equation, this discriminant must be in integers. And in order for this to be an integer, this inside the radical must be in the form of a complete square. What it means is this should be in the form of a to the power of 2. So it means that a to the power of 2 plus 3y2 equals 4. This, we should find integers for this equation, and we know that if y2 is bigger or equal than 4, then this doesn't have answer, because this would be 12, and this would be a2 equals negative 8, and so we know that the complete square cannot be negative. So y can only be negative 1, 0, and 1. Why? Because it should only has answers in integers. So let's just do a quick case check. First, let's check for y equals negative 1 or 1. So that would be, for this would be a2 equals 1, and this is correct. This you can simplify the radical, and so you can just put this in the discriminant of this and solve for x, but I'll just go ahead and substitute y values here and find for x values. So for y equals negative 1, This is x2 plus x, and this is 1 and this is -1, 0, and for y equals 1, this would be x2 minus x equals 0. For this to have answers, it is 0 and -1, and for this to have answers, this is 0 and 1. So our set of answers for here would be xy would be -1, 0, -1, and -1, and 1, 0, and 1, 1, 1. So these were our answers for these two cases, and for another case, which is, let me just quickly check it also, which is y equals 0. So for y equals 0, I'm going to also substitute the amounts here. We would get x2 minus 1 equals 0. So x minus 1, x plus 1 equals 0. And so we would have these set of answers. And I'm sorry, I read it the other way, the wrong way. Is y and x would be these answers. And so for this, we would have, for this case, we would have x, this is -1, and this is, no, this is 1, and this is -1. xy would be 1 and 0, and also -1 and 0. So we found all our answers, and let's just sum up all the answers. Let's just do a quick review of our answers, and they are in the form of, first we found our answers in form k and -k, k and -k, and if you see here, also in the form 0, -1, -1, -1, also 0, 1, 1, 1, and here is 1, 0, and -1 and 0. So let's just check if we don't have any repeated answers. No, so these are our answers for this problem, which is in integers, and hope you liked it. Please like this video. This helps me a lot, and please subscribe now and hit the bell notification, and please comment whatever you want and any recommendations you have. Thanks for watching, and bye.